What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 9, Section 3, Double Angle, Half Angle, and Reduction Formulas. Let's do it. Explain how to determine the reduction identities from the double angle identity cosine of 2x equals cosine squared minus sine squared. Okay, so the way we do that is from our Pythagorean identity, which says sine squared x plus cosine squared x equals 1. And then what we can do with this is we can do a little substitution. So, for example, if I isolate sine squared x, it's equal to 1 minus cosine squared x. So I can take this and plug it in here. So then we get cosine squared x minus, and then in parentheses, 1 minus cosine squared x. So we distribute the negative, that's negative 1, that's positive cosine squared x, plus another cosine squared x is 2 cosine squared x minus 1. So that's one of the other double angle identities for cosine of 2x. The other one comes from substitution again, but instead substituting in for cosine squared x. So here I'm going to subtract sine squared x from that original thing, and we got cosine squared x equals 1 minus sine squared x. So I'm going to take this and I'm going to plug it in for cosine squared x, right? So now I have 1 minus sine squared x minus sine squared x. These guys combine, so we get 1 minus 2 sine squared x. So there you go. That's how you get both of those. Boom, done. We can determine the half angle formula for tangent of x over 2 equals to this by dividing the formula for sine of x over 2 by cosine of x over 2. Explain how to determine two formulas for tangent of x over 2 that do not involve any square roots. So the way to get rid of these square roots is first going to be to multiply by 1 minus cosine of x over 1 minus cosine of x in a radical, okay? And that's going to get rid of this radical. So when we multiply across, the radical goes away. So I have 1 minus cosine of x on the top. And then on the bottom, something interesting is going to happen, right? We're going to have 1 times 1, which is 1. Then we're going to have 1 times negative cosine of x, which is negative cosine of x, times plus positive cosine of x. Those will go to 0. And then minus cosine squared x. But again, remember, this is all underneath a radical. Okay. Now I've got 1 minus cosine of x on top. And on the bottom, I have 1 minus cosine squared x. But what is that? So if I look at my nice Pythagorean identity, sine squared x plus cosine squared x equals 1. So this is our standard Pythagorean identity, which means if I subtract cosine squared from 1, I get sine squared. So this is the same as taking the square root of sine squared x. And the square root of sine squared x is just sine of x. So now I have 1 minus cosine of x times sine of x. So now we've gotten rid of the radicals. That's how you do it. Done. So for this one, we're going to use our double angle identities and see if we can figure this out. So first, we have a, which is sine of 2x, which is the same as 2 sine of x cosine of x. Now, I know what sine of x is, but I don't know what cosine of x is. So to figure that out, I'm going to have to draw a little triangle. So if I call this angle x, and I'm saying sine of x is equal to 1 over 8, that's opposite over hypotenuse. I can say opposite is 1, hypotenuse is 8. And then we can use Pythagorean's theorem to figure out this unknown side. So 1 squared plus, I'll call it b squared, is equal to 8 squared. So that's 1 plus b squared equals 64. Subtract by 1, we get b squared equals 63. Take the radical of both sides. Remember, 63 is really 9 times 7. So the square root of 9 is 3, and then 7 stays trapped inside. So now we have this nice triangle. Okay, so 2 times sine of x, which you already know is 1/8. And now we can calculate cosine of x, which is adjacent over hypotenuse, which is 3 rad 7 over 8, like so. And now we can multiply this out and simplify. So we get 2 times 1 times 3, which is 6 rad 7 over 8 times 8, which is 64. Divide the top and bottom by 2, and we get 3 rad 7 over 32. So that's the answer to A. For part B, cosine of 2x, we can use any of these. I'm going to use this one, 1 minus 2 sine squared x. That's just going to be the easiest. We wouldn't have even needed to figure this out, right? So that's why it's nice. So it's really the same as 1 minus 2 times sine of x. We already know is 1/8, and it's just that value squared. So 1/8 squared is 1/64. So now we have 1 minus 2 times 1/64, which is 2 over 64, which is 1 minus 1 over 32. And we can say that 1 is 32 over 32 minus that would give us 31 over 32. So that's the answer to part B. Now for part C, we need tangent of 2x, which this is the format. So it's 2 times tangent of x over 1 minus tangent squared of x. So what is tangent of x? Tangent of x is opposite over adjacent. So that's 2 times 1 over 3 rad 7. And then on the bottom, it's 1 minus tangent of x squared. So we already know that this is tangent of x. So that squared is 1 squared on top, 3 squared is 9, square root of 7 squared is 7. So 9 times 7, that comes back to 63. So now to simplify this, on the numerator, we have 2 over 3 rad 7. On the denominator, we have 1 minus 1 over 63 is really 63 over 63 minus 1 over 63, which is 62 over 63. So now just making a little room up here. Now it's the numerator times the reciprocal of the denominator to simplify further. So 2 over 3 rad 7 times 63 over 62. These can be divided by 3, and that is 21, and that's 1. And then these can be divided by 2, that's 31 and 1. And we need to rationalize that denominator as well for the final step. So I'm going to multiply the top and bottom by rad 7. So rad 7 over rad 7. I know it's messy, but now we're almost there. And then we get 21 times rad 7, which is 21 rad 7 over, and then we have rad 7 times rad 7, which is 7 times 31, but I'm not going to simplify that because I'm going to leave it like this. And then the beauty of it is 21 and 7 can reduce to 3 and 1. So now we get a final answer. Let's find a little bit more room. We're going to do it up here. 3 rad 7 over 31. And that's your answer to part C. And that is how you do it. Boom, done. So for this one, we're going to start by creating a triangle so I can figure out all the sides in this triangle so I can solve with cosine of x and tangent of x, etc. Now, if it's saying that cosine of x is negative 1/2, right, that means cosine is adjacent over hypotenuse. So I know that this side adjacent is 1 and the hypotenuse is 2, or the relationship is 1 to 2. This could be 2, that could be 4, this could be 3, that could be 6, but it doesn't matter. I can just say 1 and 2, keep it simple. Now to get the third side, I'm going to use Pythagorean's theorem, 1 squared plus that missing a squared equals 2 squared. So 1 plus a squared equals 4, a squared equals 3, which means a equals square root of 3. So here we have square root of 3. Now sine of 2x, it's the same as 2 sine of x, right, from the double angle cosine of x. Sine of x is opposite over hypotenuse, which is rad 3 over 2. But it's in quadrant 3, so sine and cosine are both negative. And then times cosine of x, which is adjacent over hypotenuse, which is, again, negative 1/2. So as we simplify this, 2 times negative 1/2 is negative 1, times negative rad 3 over 2 is positive rad 3 over 2. Cosine of 2x, let's use this identity because we already know cosine of x. So it's 2 cosine squared of x minus 1. Cosine squared so cosine of x is negative 1/2. That squared is positive 1/4 because negative times a negative is positive. So it's 2 times 1/4 minus 1. 2 times 1/4 is 1/2. 1/2 minus 1 is negative 1/2. Last but not least, tangent. So we get 2 tangent of x from this identity over 1 minus tangent squared x. Now, tangent of x is opposite over adjacent, which is rad 3. So we get 2, and by the way, tangent is positive in quadrant 3. So we have 2 rad 3 over 1 minus rad 3 squared, which is just 3. So this becomes 2 over negative 2, and we got rad 3. These cancel out, and we're left with simply negative rad 3, done. So for this question, we're meant to find the 6 trigonometric functions for theta. Now, we know that cosine of 2 theta is 3 over 5. So what I'm going to do is I'm going to use my half angle identity to sort of figure this out. But I've also created a little triangle, okay, with 2 theta. And if 2 theta is here, and I know cosine of 2 theta is 3 over 5, that's adjacent over hypotenuse. So I know adjacent is 3 and hypotenuse is 5. I'm not thinking too much about the signs because we'll deal with that later, right? They already told us that this is in quadrant 2. All right, so we'll come to that. But we can figure out this third side of this triangle because this looks like a 3, 4, 5 right triangle. And if you're not sure about that, you can always use Pythagorean's theorem. So that's pretty cool. Then I want to use my half angle identities, okay? Because if I know that cosine of 2 theta is something, right? I can now say, well, what's cosine of 2 theta over 2? This is the half angle identity. And this is equal to plus or minus, as you can see here, radical 1 plus cosine of 2 theta. That's the original thing on top, right? That's how the formula works, divided by 2. Now, since I know that cosine of 2 theta is 3/5, I've got radical plus or minus for now, 1 plus 3/5 over 2. 1 plus 3/5 is 5/5 plus 3/5, which is 8/5 divided by 2, which becomes square root of 4/5, okay? Right, because 8/5 divided by 2 is 4/5, so we got square root of 4/5. And then I can simplify this further. That becomes 2 over rad 5, right? Square root of 4 is 2. And then to rationalize the denominator, multiply by rad 5 over rad 5, and we get 2 rad 5 over rad 5 times rad 5 is 5. Now, this is really taking cosine of theta. Even though it says 2 theta over 2, it's really taking cosine of theta. And if I know that theta is in this second quadrant, then I know that this needs to be yielding a negative value, which means that cosine of theta is negative 2 rad 5 over 5. Now, what I'm going to do with this is I'm going to jump straight to secant, which is the reciprocal of cosine. It's the same sign. So since it's negative here, it's negative here. And it's going to be 5 over 2 rad 5. But again, we're going to have to rationalize the denominator by multiplying by rad 5 and rad 5. It's really going back to this, you know, before we flipped it, which was, it should be rad 5 over 2. But you'll get there the same way. So then this becomes 5 rad 5 over 2 times 5, and you'll see these cancel out. And then you get 5, as we mentioned, rad 5 over 2. And again, negative, so negative rad 5 over 2. So now we're going to do sine of theta. I had to make a little room because this is a long problem. So now sine of theta is sine of 2 theta over 2. And let's use that formula. So that's the same as plus or minus, and we'll just leave that because eventually we're going to choose one based on the quadrant and all that. It's 1 minus cosine of 2 theta, right, whatever that top angle is, over 2. And I already know that cosine of 2 theta is 3/5. So 1 minus 3/5 is really 2/5. So I got 2/5 over 2, plus or minus for now. 2/5 divided by 2 is actually 1/5. So now we got the square root of 1/5. Again, the square root of 1 is 1, and square root of 5 is square root of 5. Okay, so we're going to have to rationalize the denominator. But before we do that, let's actually use this to get cosecant, because cosecant is going to be the reciprocal of this, which is just rad 5 over 1 or rad 5. And again, since we're taking cosecant of theta, and we're talking about the second quadrant, we know that sine is positive as well as cosecant in the second quadrant. So we leave that as is. Now for the sine, we come back to this and we rationalize the denominator like so, and we get rad 5 over 5. So that's sine of theta. Now we come to the last bit, which is tangent. So we're going to use that same half angle identity. So tangent of 2 theta over 2 equals, and we can use either or. Let's just use the first one. Sine of x over 1 plus, or sorry, let's make it the top angle, so be sine of 2 theta, sine of 2 theta over 1 plus cosine of 2 theta. And what is cosine of 2 theta? We already know it's 3/5. And what about sine of 2 theta? That is opposite over adjacent, which is 4/5, okay? But we have the 1 plus 1 over here still, right? So we got 4/5 over 1 plus 3/5, which is 8/5. So we got 4/5 over 8/5. Now, hopefully you can recognize 4/5 is exactly half of 8/5. That means this simplifies to 1/2. And now again, this is tangent of theta. In quadrant 2, tangent is negative. So it's going to be negative 1/2. Cotangent is just the reciprocal of that, which is negative 2. So these are your answers. Boom, done. So this one we're meant to consolidate to a single expression. Now I see 2 sine pi fourths times 2 cosine pi fourths. First I'm going to bring this 1, 2 in front. And the reason why is because when I do that, this sure looks like the double angle identity for sine. It sure, because it's 2 sine of pi fourths and then just times cosine of pi fourths. So this is pretty cool. And then now I can just go in reverse, right? 2 sine of x cosine of x is the same as sine of 2 times whatever that angle is, which is pi fourths, all right? So now we can simplify further. It's 2 times sine of 2 times pi fourths is pi halves, so we can rewrite it like this. That's how you do it. Done. So for this one, we're trying to find the exact angle value using the half angle formula. So this is the same as sine of pi fourths, right, divided by 2. Pi fourths divided by 2 is pi eighths. Okay, so now using our half angle identity, and by the way, I'm going to pull the unit circle up here. So now I can rewrite this as the square root, just as we have up here, of 1 minus cosine of x. And again, x is this top part, right? So cosine of pi fourths over 2. What is cosine of pi fourths? Looking at the unit circle, here's pi fourths. Cosine is the corresponding x value. So it's 1 minus rad 2 over 2 over 2. Okay, so let's see if we can simplify this first. Let's make that 1, 2 over 2. So now I can rewrite it as 2 minus rad 2 over 2 over 2 again, and all this under a radical. And if all of this is being divided by 2, it's the same as multiplying by 1/2, right? So 1/2 times this gives us 2 minus rad 2 over 4. And then we got the square root of this. I can take the square root of that denominator, which is just 2. And then on top, we're trapped inside the square root 2 minus rad 2. Now the last question, is this positive or negative? Well, pi eighths was the original angle. That's in quadrant 1, of course. So quadrant 1, everything's positive. So there you go. Boom, done. So for this one, we're going to again use the half angle identity. And so we have to basically take double of this, which is sine of 11 pi over 6, which of course is on the unit circle. So that's beautiful, over 2. Okay, so what does this equal? We're taking the square root, plus or minus, but the plus or minus will be assigned based on the quadrant, so we'll come back to that. But it's basically 1 minus cosine of that angle on top over 2. So what is cosine of 11 pi 6? Here's 11 pi 6. Cosine is that corresponding x value. So it's rad 3 over 2. And then it's this divided by 2. So let's simplify a little. We'll make that 2 over 2. So now it's 2 minus rad 3 all over 2, right? 2 minus rad 3 over 2 is 2 minus rad 3 over 2. And then it's still all over 2, which is the same as multiplying by 1/2. So now we get 2 minus rad 3 over 4, taking the square root of that. I can take the square root of the denominator, which is 2, and then on top we have 2 minus rad 3 all under a bigger square root. Okay, now we come back to the sign. So originally I was taking sine of 11 pi 12ths. And 11 pi 12ths would be just under pi, so it's somewhere here in the second quadrant. And I'm taking sine of that. Sine in the second quadrant, because it corresponds to the y values, is positive. So we don't need to add a negative. That's how you do it. Done. So for this one, we're going to use the half angle identity again. And on the top, it's going to be 5 pi 6 divided by 2. And that's good because that's in the unit circle. So this is the same as tangent of 5 pi 6 over 2. Which is equal to, let's do this one, why not? Sine of x over 1 plus cosine of x. So it's sine of x, which is that top part, 5 pi 6, over 1 plus cosine of that same angle. All right, so what is sine of 5 pi 6? Here's 5 pi 6. Sine is the corresponding y value, so it's 1/2 over 1 plus, and then cosine of 5 pi 6 is the corresponding x value, so that's negative rad 3 over 2. Okay, let's simplify. So then we have 1/2 over, I want to get common denominators. This is 2 over 2. So then 2 over 2 plus negative rad 3 over 2 is 2 minus rad 3 over 2. Last but not least, to simplify, we multiply the top by the reciprocal of the denominator, which is 2 over 2 minus rad 3. The 2's cancel, and we get 1 over 2 minus rad 3. Now to rationalize the denominator, we multiply by the conjugate of 2 minus rad 3, which is just 2 plus rad 3. We just flip the minus to a plus, like so. And on top here, let's go up here. On top, we have 1 times 2 plus rad 3, which is 2 plus rad 3. On the bottom, we have 2 times 2, which is 4. Then we have 2 times rad 3, 2 rad 3, negative rad 3 times 2, negative 2 rad 3. They cancel out. Negative rad 3 times rad 3 is negative 3. 4 minus 3 is 1, which leaves us with simply 2 plus rad 3. Boom, done. So for this one, we're going to use the half angle identity. Tangent of half of that, or actually double this, negative 3 pi fourths, but then divided by 2. So that's how we use the half angle identity. So then let's use the first one. It's kind of arbitrary, but let's just use that one. So it's sine of the top angle, negative 3 pi fourths over 1 plus cosine of negative 3 pi fourths, okay? And now remember, what is negative 3 pi fourths? It's going back in this direction, right? Otherwise, 3 pi fourths would be here, but now we're going in this direction, which would land us at 5 pi fourths. So it's the same as 5 pi fourths, right? So what is sine of 5 pi fourths? It's the corresponding y value, negative rad 2 over 2 over 1 plus cosine of that, which is the same thing. The x value is the same thing. It's also negative, so it's negative rad 2 over 2. All right, now I want to rationalize the denominator. Now I want to make common denominators with this 1 and this, so I'm going to make that 2 over 2. So then it now becomes negative rad 2 over 2 divided by 2 minus rad 2 over 2. All right, it looks complicated, but then I'm going to multiply by the reciprocal of this against the numerator. So let's do it up here. We got negative rad 2 over 2 times 2 over 2 minus rad 2. Yikes. Okay, these cancel out. Then I have negative rad 2 over 2 minus rad 2. Last but not least, let's rationalize that denominator by multiplying by the conjugate of this, which is just 2 plus rad 2, right? It's the exact same. You just flip the minus to a plus or plus to a minus, whatever, okay? So then on the bottom, we get 2 times 2, which is 4. Then 2 times rad 2, 2 rad 2, negative 2 rad 2. Those cancel out. They add to 0. And then negative rad 2 times 2 is negative 2. So that's what's on the denominator. How about the numerator? Negative rad 2 times 2 is negative 2 rad 2. And then negative rad 2 times rad 2 is negative 2. So this becomes 2. Now we divide both of those by 2, and we get negative rad 2 minus 1. Boom, done. So for this one, before we get going, I want to start with the little triangle, and I'm going to put x in here as my angle. And since I know that sine of x is 12 over 13, it's negative, but we'll come back to that. I know that opposite x is 12 and the hypotenuse is 13. Next, you can use Pythagorean's theorem to find the missing side. But if you recognize that it's a Pythagorean triple, 5, 12, 13, which I do, I can just put in a 5 here. So we're good there. All right, now let's find everything. And again, it's telling us that x is in quadrant 3, so that's important. So now sine of x over 2 using the half angle identity, that's the same as the square root of 1 minus cosine of x over 2. What is cosine of x? Adjacent over hypotenuse. So it's 5/13. By the way, cosine is negative in quadrant 3. So that is radical of 1 minus negative 5 over 13 over 2. And that becomes a double negative, that's a plus. So 1 plus 5 over 13, that's 18 over 13. So we got 18 over 13 divided by 2. So it's the same as multiplying by 1/2, which is the same as taking half of the 18. So it's now square root of 9 over 13. Square root of 9, and we're low on room. Your square root of 9 is 3. And then square root of 13, square root of 13. Last but not least, let's rationalize by multiplying by rad 13 over rad 13, and we get 3 rad 13 over 13. So that's part A. And by the way, I know this final answer is positive because if x is in quadrant 3, half of x is going to be in quadrant 2. Imagine, right? One angle could be 240. Half of that is 120, quadrant 2. Imagine it could be 186. Half of that is 93, again in quadrant 2. So quadrant 2 sine is positive. All right, now what about cosine of x over 2? So that is radical 1 plus cosine of x over 2, okay? And we already know what cosine of x is. It was negative 5/13. So this is 1 minus 5 over 13 over 2, all under the radical. 1 minus 5 over 13 is 8 over 13. And half of that is 4 over 13. So we got something similar. This is going to be 2 over rad 13. Multiplied by rad 13 over rad 13. We get 2 rad 13 over 13. Now, we already said that half of this angle is in quadrant 2. So since we're in quadrant 2, cosine in quadrant 2 is negative. So we get negative 2 rad 13 over 13. Last but not least is this tangent of x over 2, and we're going to use sine of x over 1 plus cosine of x. So sine of x, as we already know, is negative 12 over 13. And then cosine of x, which we already figured out, but let's do it again. It's adjacent over hypotenuse, which is 5 over 13. Again, we're in quadrant 3, so that's negative 5 over 13. So it's 1 minus 5 over 13, okay? So then we have negative 12 over 13 on the numerator. On the denominator, 1 minus 5 over 13 is positive 8 over 13, right? So that's 8 over 13. So we'd multiply by the reciprocal of the denominator, which is 13 over 8. So then the 13s cancel out. We get negative 12 over 8, which reduces to negative 3 over 2. And this makes sense that it's negative because, again, half of this angle is going to be in quadrant 2, and tangent is negative in quadrant 2. So there are your answers, done. So for this one, we're going to start with a little triangle to figure a couple things out. And by the way, what we need to find is half angles for sine, cosine, and tangent. And since we know secant of x is negative 4, so if I put an x here, secant, so it's related to cosine, right? Cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So I can call the hypotenuse 4 and the adjacent side to that 1. And then we can figure out the last leg by using Pythagorean's theorem, 1 squared plus x squared, or actually let's call it b squared, so we already have x as the angle. B squared equals 4 squared, which is 16, which means b squared equals 15, which means this other side is going to be the square root of 15, okay? So now let's use these half angle identities. So sine of x over 2 is the same as square root of 1 minus cosine of x over 2. So what is cosine of x? Adjacent over hypotenuse, 1/4, right? So we've got, and by the way, if secant is negative, cosine is also going to be negative. So it's actually negative 1/4. So 1 minus negative 1/4 over 2, and that's the same as plus, so that's 5/4 over 2 radical, and then that's basically half of 5/4, which is 5/2, right? Divided by 2 is, I'm sorry, not 5/2, 5/8, excuse me. So now we have square root of 5 over 8. Now the denominator can be simplified to 2 rad 2. Last but not least, I'm going to multiply by rad 2 over rad 2, and we get rad 10 over 2 times rad 2 times rad 2, that's 2 times 2, which is 4. And by the way, since x is in quadrant 2, half of x will be in quadrant 1. So this should give us this, and that's positive. Now moving on to the second part. So cosine of x over 2 is square root of 1 plus cosine of x over 2. All right, so once again, we know that cosine of x is negative 1/4, so we got radical of 1 minus 1/4 over 2. That's square root of 1 minus 1/4 is 3/4, and then divided by 2, or half of 3/4, is 3/8. And so once again, this simplifies to rad 3 over 2 rad 2. Last step, multiply by rad 2 over rad 2. And we get here, let's see if I can find some room. Rad 2 times rad 3 is rad 6. And then that's 2 times rad 2 times rad 2, which is 4. So there's my answer for part B. Just to reiterate, this is positive because x over 2, once again, is in quadrant 1. All right, last but not least, tangent. So we have sine of x over, I'm just choosing the first one, sine of x over 1 plus cosine of x. All right, what is sine of x? Opposite over hypotenuse, which is rad 15 over 4. And we know that x is in quadrant 2, so sine in quadrant 2 is positive, so that's cool, over 1 plus, and then cosine of x is 1 over 4, but again, it's negative because we're in quadrant 2, negative 1/4. And this simplifies to rad 15 over 4 over 1 minus 1/4 is 3/4. So then to further simplify, we've got rad 15 over 4 times the reciprocal of 3/4, which is 4/3. Cancel, cancel, and we're left with rad 15 over 3. Again, that's positive because this is quadrant 1. So that's how you do it. Boom, done. So for this one, it says find sine of 2a, cosine of 2a, tangent of 2a. Here's a, right, or alpha. Okay, let's go ahead and calculate these using these double angle identities. And by the way, what is the hypotenuse? If this is 5, this is 12. Yeah, we can use Pythagorean's theorem, but this is also a Pythagorean triple, 5, 12, 13. Okay, so what is sine of 2a? First of all, sine of 2x is going to be 2 sine x cosine x. So this part is going to be 2 sine a cosine a. So what is sine of a? Sine of a is opposite over hypotenuse. So that is 13, I'm sorry, 12 over 13. And what is cosine? Adjacent over hypotenuse. So that's 5 over 13. And then as we multiply it out, we get 2 times 12 times 5. That's 120 over 169. So that's sine of 2a. And by the way, this is going to stay positive because if we say angle A, right, let's say it's some acute angle, double angle A is going to likely go into quadrant 2. The reason why I say that is because for this 5, 12, 13, A is clearly bigger than 45, right? Because then this would be an isosceles right triangle. I know it's bigger than 45. It has to be because it's opposite the larger leg. So it's got to be like in the 60s or 70s. So we know we're in in quadrant 2. In quadrant 2, sine is positive. Okay, now let's go to cosine. And by the way, in quadrant 2, cosine is negative, so is tangent. So the next two answers are going to be negative. Okay, so back to this. Cosine of 2a, here's the formula. Which one should we use? Let's use 1 minus 2 sine squared. It's just random. Any of them will give the same response. But we get 1 minus 2 sine squared of a. So what is sine of a? Opposite over adjacent. So it's 12 over 13. And again, we're squaring this and multiplying it by 2 and then subtracting by 1. So 12 over 13 squared, that's 144 over 169 times 2 is 288 over 169. And then 1 minus this, I can rewrite 1 as 169 over 169. So then when I minus these, I get negative 119 over 169. Okay, so that's cosine. And see, it makes sense that it's negative. That's your cosine of 2a. Last but not least, we get to tangent of 2a. So here's the formula. So we got 2, let's write up here, 2 tangent of a over 1 minus tangent squared of a. So what is tangent of a? That's the question, right? It's opposite over adjacent, 12 over 5. So we get 2 times 12 over 5 over 1 minus 12 over 5 squared, which is 144 over 25. So let's simplify this. 1 can be rewritten as 25 over 25, so we can simplify that denominator. So then, man, we're running low on room here, so let's get rid of this. So on the denominator, we have negative 119 over 25. On the numerator, we have 24 over 5. Last step, we multiply the numerator by the reciprocal of the denominator, which is 24 over 5 times 25 over 119 negative. And these will cancel out to become 5 and 1. So last but not least, we have 25 times negative 5, which is negative 120 over 119. That's tangent of 2a. That's how you do it. Done. So for this one, we're trying to find sine, cosine, and tangent using the half angle identities. So that's why we got them up here. So let's start first with sine of a over 2. And by the way, we got a 5, 12, 13, because this is a Pythagorean triple, 5, 12, 13. If you don't have that memorized, you can do 5 squared plus 12 squared equals what? And it would be 169. Square root of that is 13. Okay, so what is sine of a over 2? And by the way, every single one of these should be positive, okay? Because we're taking an angle in a triangle, we're dividing it by 2. That's quadrant 1, right? So all of these should give us positive values. Now, this would be, sine would give us, we'll start with square root of 1 minus cosine of a over 2. Okay, and what is cosine of a? Adjacent over hypotenuse. That's 5 over 13. So we got rad 1 minus 5 over 13 over 2. 1 minus 5/13 is actually 8/13, and then that divided by 2 is like multiplying this by 1/2. So it really becomes 4 over 13. And this simplifies to 2 over rad 13, because square root of 4 is 2. And then to rationalize the denominator, multiply by rad 13 over rad 13, we get 2 rad 13 over 13, because rad 13 times itself is just 13. So there is this part. Now we get cosine of a over 2. It's the same thing, except for instead of the minus, it's plus. So we can jump straight in to this point, and we say it's 1 plus 5 over 13 divided by 2. 1 can be written as 13 over 13. That's 18 over 13 divided by 2, okay? And then 18 over 13 divided by 2 is like multiplying this by 1/2, so it becomes 9 over 13. Square root of all of it, right? Square root of 9 on top is 3. That stays as a square root in the bottom. Then to rationalize the denominator, multiply like this, and we get 3 rad 13 over 13. Okay, so that's this cosine of a over 2. Last but not least, we need to do tangent of a over 2. So that's sine of a over 1 plus cosine of a, where sine of a is opposite over hypotenuse, which is 12 over 13 over 1 plus cosine of a, which we already figured out here. 1 plus cosine of a was 18 over 13. So we got 12 over 13 times the reciprocal of the denominator to simplify. 12 over 13 times 13 over 18, cancel, cancel. We get 12 over 18, which simplifies to 2/3. So the last one is 2/3, boom, done. For the following exercises, simplify each expression, do not evaluate. So we got 2 cosine squared of 37 minus 1. So this one says for the following exercises, simplify and do not evaluate. So we got 2 cosine squared of 37 minus 1. That looks a lot like this, which is part of the double angle identity cosine 2x, which means whatever this angle is, 37, I can double it to 74 and simplify as this being literally cosine of 74. So we're not going to evaluate it, but that's how you simplify it. Done. So for this one, we're meant to simplify it, and cosine squared of something minus sine squared of something, that looks like this, right? So it's obviously going back to the cosine double angle, which means it's the same as saying cosine of double whatever this is, which is 18x. So that's how you do it. Done. So this one here reminds me of this, with the exception of a 6 instead of a 2. So why don't I pull a 3 out, and then I can call it 2 sine 5x cosine 5x. Now this whole part in here looks like this, so I can rewrite that as sine of double whatever this angle is, so that'd be 10x. So it's sine of 10x like that with the 3 out front, boom, done. So for this one, to verify the trig identity, what I'm going to do is I'm going to first acknowledge the fact that sine is odd, cosine is even. That means if cosine is even, cosine of negative x is the same as cosine of x. And sine of negative x is the same as negative sine of x. And then we got that negative 2 out in front. These two negatives are going to cancel, and then we're left with 2 sine x cosine x. And then 2 sine x cosine x is the same as sine of 2x. So there you go. That's how you verify it. Done. So for this one, I'm going to start by applying the double angle there and there. So sine of 2x is the same as 2 sine, and I'm going to use x instead of theta. It's just easier to write. 2 sine x cosine x over 1 plus, and then cosine of 2x, I can use one of these three. So I'm going to choose this one because the ones are going to cancel out. So it becomes 2 cosine squared x minus 1. So these cancel out, these cancel out. Then one of the cosines in the top and bottom are going to cancel out. Now remember, we still have a tangent squared x here, but we'll deal with that in a second. So then, and by the way, the 2's are going to cancel now, and then one cosine cancels, so that goes, and then 1 stays in the bottom. So now we have sine of x over cosine of x times tangent squared x. Well, guess what? Sine of x over cosine of x is the same as tangent x, and then tangent times tangent squared is tangent cubed x. So that's the same as what we have here. Again, I just changed it to x instead of theta, but same thing. That's how you do it. Done. So for this one, I have to rewrite this with an exponent of only 1. So I'm going to choose to use my cosine half angle identity. Okay. And remember, this is really, this is the same as just saying cosine of 6x squared. The entire thing is being squared, right? So let's rewrite it as this is cosine of, we'll say 12x over 2. It's the same as 6x, right? So first, using my half angle identity, let's rewrite that. And by the way, this whole thing is going to be squared. So then that is square root of 1 plus, and then it's cosine of the x on top. So 1 plus cosine of 12x. And then on the bottom, we have 2. And again, all of this is being squared. So that just kills the square root, right? Squaring and the square root just cancel out. So we're left with 1 plus cosine of 12x, and now over 2. And now we've satisfied that this has to be to an exponent of 1. So that's how you do it. Done. So this one's going to take quite a bit of work because it's to the 4th power, and we're going to start by using our nice half angle identity. So 3x is the same as 6x over 2. Remember, all of this is to the 4th power. So we can say that sine of 6x over 2 using this is the same as the square root of 1 minus cosine of 6x, that value on top, right, over 2, and all of this to the 4th power, okay? And if I square this, the square root goes away. So I can say it's 1 minus cosine of 6x over 2. and then it's this amount squared, because squaring it once gets rid of that radical. Squaring it twice would then be to the fourth power. So I can consider this as this value squared, or an easier way to write this out, it'd be this times itself, right? Okay, now we're gonna FOIL and we're gonna see what we get. So we get 1 minus 2 cosine of 6x, and then plus cosine squared of 6x, okay, over 2 times 2, which is 4. But then again, we have another problem, right? That's to the second power. We need everything to be to the first power. So we're going to run this through the double angle identity again. I'm going to make some room up here. So cosine squared of 6x, I'm going to rewrite that as cosine of 12x over 2, and this amount squared. And cosine of 12x over 2, well, we can put it in here, and that's the square root of 1 plus cosine, again, of that top angle 12x over 2. And we're squaring this, so it kills the square root. So now we have, this will be replaced by what's underneath here. So now we have 1 minus 2 cosine 6x plus 1 plus cosine of 12x all over 2, and all of this over 4. So notice what I did. I deleted the unit circle. We don't need it for this problem anymore anyway. So now we got this, and now we have to further simplify it. So let's first get this over 2. So I'm going to multiply this by 2 and put it over 2. So then we have common denominators. So then I have 2 minus 4 cosine of 6x plus 1 plus cosine of 12x, and all of this is over 2, right? This is already over 2. This will become over 2. And then all of this is going to be over 4. So now we can kind of combine like terms. 2 and 1 make 3. So then I have 3 minus 4 cosine of 6x plus cosine of 12x. And by the way, this is all going to be over 2, but then we're dividing it by 4, so it's really over 2 times 4. Because I would have end up multiplying by the reciprocal of that, which is 1/4. So 4 times 2, we're now over 8. So here is the final answer. Boom, done. So for this one, we're going to start by recognizing cosine of x to the 4th. I can rewrite it like this, and then sine will rewrite like this. I mean, it's the same thing, right? It means the same thing. It's just going to be easier for us now from this point. Now, I'm going to use my half angle identities. So I'm going to make this cosine of 2x over 2. I'm going to make this sine of 2x over 2. Okay, let's deal with this one first. So it's going to be the square root of 1 plus cosine of this upper argument, which is 2x over 2. And it's this to the 4th power. So really, it's squared twice. So you square it once, and it's 1 plus cosine 2x over 2. And then we're squaring it again, so it's this squared. Now, I'm not going to write it completely out, but imagine foiling this. Of course, squaring the 2 is going to give you 4 on the bottom. And then on the top, imagine 1 plus cosine 2x times 1 plus cosine times 2x, which is going to be 1 plus 2 cosine 2x plus cosine squared 2x, right? And again, that's from foiling. But now we have a squared here, so we're going to have to deal with that. So I'm going to rewrite that as cosine of 4x over 2, so I can use this half angle identity again. And again, this whole thing is going to be squared. So cosine of 4x over 2 can be rewritten as the square root of 1 plus cosine of 4x over 2. And it's all of this squared, which just kills that square root. So that's the same as 1 plus cosine 4x over 2. All right, now we're adding it to these two guys, right? And I'm going to throw those over 2 by multiplying it by 2 over 2. We got fractions and fractions happening. Just bear with me, but it'll make sense in a second. So then it's 2 plus 4 cosine 2x, all of this over 2. And these two are just adding together, right? So now I can add the like terms. 2 plus 1 is 3. And then these are not like terms. So we got 3 plus 4 cosine 2x plus cosine of 4x, and this is over 2, and then this is all over 4. But really, it's multiplying by the reciprocal of 4, which is 1/4, which means it's going to be this thing times 1/4, which is going to be 2 times 4, which is 8. So then this whole thing now goes to 8. So that's what this kind of simplifies to, is that. All right, now let's deal with the sine of x squared. So this is a little easier. Sine of x is just, sine of 2x over 2 squared is going to be 1 minus cosine of 2x over 2 squared, and that just kills the square root, right? So that one's pretty easy. That's just 1 minus cosine of 2x. So now what we're doing is we're multiplying this, all right, I know this is getting crazy, but we're getting there, times this, 1 minus cosine 2x. Okay, so I had to erase some stuff to make some room. So now we're going to distribute, right? 1 times this, times this, times that. That's literally the exact same thing. And then it's cosine, negative cosine of 2x times this, this, and this. So then that's minus 3 times cosine of 2x. And then negative cosine of 2x times 4 cosine of 2x is negative 4 cosine squared of 2x. And then last but not least, negative cosine 2x times cosine of 4x is negative, they're not like terms, right? So it's just negative cosine of 2x times cosine of 4x, okay? So this whole thing up here, this whole bit is the numerator. And then the denominator is 2 times 8, which is 16. So we'll come back to that. Let me now combine like terms. So we've got a 4 cosine 2x and a negative 3 cosine 2x. So let's consolidate a little bit. So now we got this all over 16. The last thing we got to deal with is this. So we're going to deal with that now. I'm going to make some room down here, and then we're going to simplify that so it doesn't have a power to the second power. So that's the same as negative 4 times cosine of 4x over 2. That's the same as 2x, right? 4x over 2, and then it's this whole thing being squared. So cosine of 4x over 2 can be rewritten as the square root of 1 plus cosine of 4x over 2, and this value squared, and then there's still a negative 4 in front. So squaring the square root kills that. Then I can multiply in the negative 4, first by dividing by 2, so then it's negative 2. So then it becomes negative 2 minus 2 cosine 4x. And this whole thing here is equivalent to this. So now with this, we can simplify everything. So I'm going to erase and make some room, and then we're going to see the final answer. So the 3 is going to combine with the negative 2 and make 1. The negative 2 cosine 4x is going to combine with this cosine 4x, making just negative cosine of 4x. This cosine of 2x is just chilling, so we got plus cosine of 2x. And then we have this, minus cosine 2x cosine 4x. And all of this is over 16. So now we satisfied it. Everything is to a power of 1 for cosine. And just as an FYI, this is different than what's in the back of the book, but it's also equivalent. You can check it in Desmos and see that they map to the exact same graph. So in my opinion, this satisfies the condition, so this is legit. Anyways, that's that. Boom, done. So I'm going to start by making this tangent of 2x over 2, and all of this to the 4th power, okay? And I'm going to do this in a specific way to make it as easy as possible, because first of all, tangent of 2x over 2 can be rewritten using this, which would be sine of 2x over 1 plus cosine of 2x, okay? And now it's this to the 4th power. But I could also rewrite it like this. What I'm going to do here is since there's 4 of these that are multiplying, I'm going to write 2 of these, aka this squared, and then the second 2, I'm going to write it in this format, which is totally allowed. 1 minus cosine of x over sine of x. And this is just going to make it a lot easier. Now let's square each of these individually. So if I square, oh yeah, sorry, that's supposed to be 2x, 2x. Okay, now if I square the one on the left, it's going to be sine squared 2x over, and then imagine we're foiling this, right? So it'll be 1 plus 2 cosine 2x plus cosine squared 2x, all right? And then it's multiplying against this one, which is on the bottom going to be sine squared 2x. And then on top, it's going to be 1 minus 2 cosine 2x plus cosine squared 2x, all right? Now, since this is multiplying, these are going to cancel. And then the only thing we have to deal with is this and this. These are the only things to the 2nd power. So first, we've got on the numerator 1 minus 2 cosine 2x. And then what is cosine squared 2x? I can rewrite that as cosine 4x over 2, just so I can use the half angle identity again. And this whole thing squared. And then that becomes right here 1 plus cosine of 4x over 2 under radical. But then it's that squared, so it just becomes 1 plus cosine 4x over 2. So this is plus 1 plus cosine 4x over 2. And then in the denominator, We have 1 plus 2 cosine 2x, and then that's the same thing, plus 1 plus cosine 4x over 2, because we already figured that out, right? Cosine squared 2x is this. Okay, last step to kind of simplify. I'm going to multiply the top and bottom by 2 and 2, right? 2 over 2, so it doesn't change it. It's like multiplying by 1, and then this is just going to simplify everything. So then this becomes 2 minus 4 cosine 2x, and then that just kills the denominator there, so then it's just plus 1 plus cosine of 4x on the top, and then on the bottom we have 2 plus 4 cosine 2x, and then that kills the denominator, plus 1 plus cosine of 4x. Now the 2 and the 1 make 3, so that's 3 minus 4 cosine 2x plus cosine of 4x over, and then 2 plus 1 is again 3 plus 4 cosine 2x, and then we have plus that cosine 4x at the end. Whew, okay, there we go. That's how you do it. Boom, done. So for this one, I'm going to rewrite sine as sine of 2x over 2, and this whole thing squared. And cosine, same thing as cosine of 2x over 2, and then this whole thing squared. So this can be rewritten based on the half angle identity as square root of 1 minus cosine of 2x over 2, and this is still squared. And then this is square root of 1 plus cosine of 2x over 2, and this is also squared. So the squares just kill the radicals. So now I have 1 minus cosine of 2x over 2 times 1 plus cosine of 2x over 2. So these guys are multiplying. So now let's distribute this and FOIL this. So we got 1, and then plus cosine 2x minus cosine 2x, they cancel out, minus cosine squared 2x, and then 2 times 2 is 4. Now we got to deal with this. So I'm going to rewrite this as cosine of 4x over 2. Again, just so I can use my half angle identity and get rid of that second power, and it's this squared. So this is the same thing as square root of 1 plus cosine of 4x over 2 squared, which just kills the square root. So then this becomes 1 minus 1 plus cosine of 4x over 2, and all of this over 4. It looks pretty messy, right? But we're getting there. It's going to look nicer in a second. Then I'm going to multiply the top and bottom by 2. So then here I get 2, and then that's just going to kill the denominator here. So then it's just minus 1 minus cosine of 4x. That's just because I'm distributing the minus like that, right? So they're both negative. And then this is over 8. Last but not least, 2 minus 1 is 1, so our final answer is 1 minus cosine of 4x over 8. Boom, done. So for this one, I'm going to use a little bit of a hack to make this easier. I'm going to convert tangent to the fourth to sine to the fourth x over cosine to the fourth x. And then again, it's times cosine squared x. So this is legit because that's an identity. Sine over cosine is tangent. So sine to the fourth over cosine to the fourth is tangent to the fourth. Then this is going to cancel out with this, and it's going to be cosine squared. So now I have sine to the fourth x over cosine squared x. This is going to be easier to execute. And by the way, so let's start converting. And I'm going to rewrite this as sine of 2x over 2, and this whole thing to the fourth power, over cosine of 2x over 2, and then this squared. Okay, so this is going to allow us to use these half angle identities. So cosine's pretty easy, right? It's square root of 1 plus cosine of this upper argument divided by 2, and then that's squared, which is just going to kill that radical, which means for the denominator, I simply have 1 plus cosine of 2x over 2. That's nice. Now, what about this numerator? It's going to be the square root of 1 minus cosine of 2x over 2 squared, actually to the fourth power, which really is this without the radical to the second power, right? So it becomes 1 minus cosine of 2x over 2, basically squared, okay? So now let's FOIL that, and that becomes, 1 minus cosine 2x times 1 minus cosine 2x, which would be 1 minus 2 cosine 2x plus cosine squared 2x, okay? Because that's what, you FOIL it out. You can't just say, oh, it's 1 squared and cosine 2x squared. No, you got to FOIL it. And then 2 squared is 4. And then on the denominator, we got 1 plus cosine 2x over 2. All right, we have another squared situation. Before I kind of merge this and simplify, we have another squared situation. I already know with cosine squared, I'm going to go with that half angle identity. So this is the same as saying cosine of 4x over 2 squared, which means I can now use this and say it's square root of 1 plus cosine of 4x over 2 squared, which really just means we're killing that radical, so let's not even include that. So now I can plug that back in for this. So these problems are a doozy, so I gotta make some room. So then we got 1 minus 2 cosine 2x, and then it's plus, and then I'm replacing this with this, plus 1 plus cosine 4x over 2, little fraction and a fraction and a fraction. So then it's this over 4, and then it's this over 1 plus cosine 2x over 2. Now what I'm going to do is I'm going to multiply this numerator times the reciprocal of this. I'm not going to write it all out because it's crazy, but it's basically this multiplies that, and this 2 multiplies the entire numerator. And you can see how beautifully this works out. So then on that denominator, I've got 4, and I'm going to leave it how they have it in the answer. I've got 4. I'm not going to distribute the 4. I've got 4 times 1 plus cosine 2x. Of course, I can distribute the 4. I'm just, like I said, not going to do it, so it's a little easier. And then the 2 is going to come up here, and it's going to multiply everything, right? Which is going to make that numerator here. We're still going to have, so it's going to be, and I'm going to write it separately here because I'm going to put the final up here. It's going to be 2 minus 4 cosine 2x, and then the 2 is going to wipe out this fraction to make it, or clear out that denominator to make it 1 plus cosine of 4x. Okay, and then last but not least, 2 plus 1 is 3, and then we got minus 4 cosine of 2x, and then plus cosine of 4x, like so. And here is your final answer. Man, oh man, boom, done. So for this one, we only have to deal with this cosine squared, so I'm going to make that cosine of 4x over 2 squared, so we can use this nice half angle identity right here. So this is the same as square root of 1 plus cosine of this upper value, 4x over 2, and then this squared, it just basically kills the radical. And then it's this amount times sine of x. And pretty much just to simplify it how they have it in the answers, it's 1 plus cosine of 4x, like so, times sine of x. We need another parenthesis here, and maybe 1 in here just for good measure, all over 2. That's how you do it. Boom, done. So for this one, I'm going to use my double angle identity to find something equivalent. So first of all, so it says sine of 2x equals 2 sine x cosine x. So that's the same as 2 sine of, and then it's going to be half of this. Right here, it's 2x goes to x. Here it's 4x, so it's going to go to 2x. Sine 2x cosine 2x. And then I can reapply this again. So then, sine of 2x is going to become 2 sine of regular x cosine of x, and then cosine of 2x we can use whichever one of these we want. Maybe let's use this one, cosine squared minus sine squared. So that's cosine squared x minus sine squared x. And then all they did in the answers to simplify is just distribute that 2 in, so then we end up with 4 sine x cosine x times cosine squared x minus sine squared x. That's how you do it. Boom, done. So for this one, we're meant to prove this identity. So let's do that now. And by the way, this really looks to me like the tangent identity for double angle identity. So let's just think about that. So to prove this identity, what I'm going to do is I'm actually going to take the right side because it's going to be easier. And I want to get this sine of 2x. So I'm going to first rewrite the tangent, which I can, that's an identity, as sine of x over cosine of x. Same with that denominator. That's tangent squared is sine squared x over cosine squared x. Now I'm going to make common denominators on the bottom. So then on the top, I still have 2 sine x cosine x. And then that 1 is going to turn into cosine squared over cosine squared. So then we have cosine squared x plus sine squared x over that nice common denominator, cosine squared x. Now we have another great identity that has just appeared. The Pythagorean identity, sine squared plus cosine squared is 1. So now I can rewrite all of this as 2 sine x cosine x over 1 over cosine squared x, right? Now I can multiply by the reciprocal of this, which is just cosine squared x over 1. And then cosine squared is going to cancel out with that cosine x. So now we're left with 2 sine x cosine x. And guess what? 2 sine x cosine x, that is sine of 2x. So now we're down to sine of 2x, which is on the left-hand side. We've proven the identity, boom, done. So here what I'm going to do is I'm going to take the right-hand side and see if we can get it into this. So first of all, I see on the top 2 sine x cosine x. That looks like this. So I can rewrite the top right off the bat as sine of 2x. That's pretty cool. What about the denominator? Well, wait a minute. I see 2 cosine squared x minus 1 right here, which means that 2 cosine squared x minus 1 is the same as cosine of 2x. And guess what? Sine of an argument over cosine of the same argument is simply tangent of that argument, which is what we had on the left side, which means we just verified the identity. Boom, done. So here what I'm going to do is I'm going to use the sine sum identity to see if we can get this. So check this out. I can rewrite sine of 3x as sine of x plus 2x, right? And now if I use this formula, it's the same as sine of x times cosine of the second argument, which is 2x, plus cosine of the first argument, sine of the second argument. Now what I can do is use the double angle identities for this and this. So I'm going to turn cosine 2x into this, cosine squared minus sine squared. And for sine of 2x, we only have one choice, which is 2 sine of x cosine of x. Now let's simplify. So I'm going to distribute, that's sine x cosine squared x minus sine cubed x. And then here we have plus 2 sine of x cosine squared of x, because cosine times cosine, right, is going to be cosine squared. Last but not least, we combine like terms. So 2 of that and 1 of that makes 3. So that's 3 sine x cosine squared x minus sine cubed x. And guess what? That's what we have on the right side. This has been verified. Boom, done. So for this one, we're trying to verify this identity. I'm going to go with the left side and use my double angle identities. And I know they have t here, but I'm just going to use x. It's easier to write. So we got 1 plus cosine of 2t or cosine of 2x can be rewritten as any of these three. I'm going to choose this one because I got cosine here on the numerator. So let's leave cosine in the mix. So I got 2 cosine squared x minus 1. And then for the denominator, we've got sine of 2t. We only have one option for that, which is 2 sine x cosine x. And then it's minus our typical cosine of x. Now on the top, these two are going to cancel out, right? 1 minus 1. And then we got 2 cosine squared x over all of this. Now I can divide everything by cosine of x. That has a cosine of x, so does that, so does that, okay? And so now I have 2 cosine of x, not cosine squared, 2 cosine of x on top over, and then that becomes 2 sine of x, and then cosine of x divided by cosine of x is 1, so it's 1. And this is the exact same thing we have here. Again, just we have x's instead of t's. I just replace it again because it's easier to write. But that's how you do it. It's verified, done. All right, here we are, last problem. This one looks really crazy. So anyways, as we verify this, I'm actually going to simplify the right-hand side, okay? Because I'm right off the bat observing that this looks a lot like this, right? Cosine squared minus sine squared, and they have the same argument. So that consolidates to simply cosine of double this. So that consolidates to cosine of 8x, and then we'll leave that as is for now, minus sine of 8x. Now I can do something similar here, cosine squared minus sine squared. Once again, that's going to simplify to, well, it's literally the same thing, cosine of 8x, and then plus sine of 8x. Okay, so this is pretty cool because look, now I have kind of a difference of squares situation happening. I can distribute, and then I get cosine squared of 8x, and then I get cosine 8x sine 8x, negative cosine negative cosine 8x sine 8x. So those are going to cancel out. And then we get minus sine squared 8x. Now this is beautiful because once again, I have cosine squared minus sine squared with the same argument. So that's right here, which means I can backtrack to my double angle identity, which is cosine simply of double 8, which is 16, double 8x, which is 16x. And guess what? That is what we had originally on the left side. Verified, done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.